And welcome back to Turtleberg Channel. Today's video is on reviewing for the final exam term 1. And the first thing I'm going to look at if you've got my review. It's number 14. I think this is a very important problem. Somebody just finishing their first semester of physics needs to be able to do. And that's this classic Atwood's problem. And I'm not going to draw the free body diagram. Well, yes, I will. I can't help myself. If you remember when you do this problem, you have two free body diagrams. You have one for each object. And so for one of them, you'll have a T going up and a M1G going down. The other one, you'll have a same T going up and a M2G going down. And then what you'll do is come back and write a sum of the forces Y for each one of those, which would be T minus M1G equals the other one, sum of the forces Y would be T minus M2G. And now if you remember, the only trick is this that we will employ in this, and this is my little method of doing it. I will make the one going up, I will make it equal to positive M1A, and I'll make the one falling equal to negative M2A, and you can say it, the physics is over at this point. And so what we'll do next is I'll solve one of these. How about this guy? I'll solve it for t. T equals m1a plus m1g. And now we'll bring that into the other equation. m1a plus m1g. And you could plug in numbers anytime you wanted to at this point. Equals negative m2a. Matter of fact, let's go ahead and plug in. I think the numbers in our review is 2 and 7 are the two masses. So this would end up being M1. M1 is 2A plus 2G minus 7G equals negative 7A. So now we need to combine all our like terms and everything. And so as for me, what I'm going to do, this is going to be 9A equals, and we need to take this and bring to the other side. And you could go ahead and multiply out your g's if you wanted to. I was just leaving them for now. So that would end up being 5g on the other side. And so 5 times 9.8 for my 5 times g divided by 9 equals 5.44. And if you can remember correctly, the answer to this should always be less than 9.8. If you want to solve for t, I'm not, but if you want to solve for t, just substitute back in and get your t. I think that is a really, really, really good problem. So now you're probably wondering, well, can you think of any more really, really good problems on here? Most of them I think are a little bit more. I think what we ought to look at next maybe is like a basic projectile like number 10, because I gotta want to have a projectile. Number 10 has a daredevil being shot out of a cannon at 45 degrees and 31 meters per second. And it looks like he's being shot at a net that is somewhere, I don't know where, but somewhere out here, a net that is positioned a distance of 48 meters away. Well, if you remember my goals on every projectile problem, first thing I'm going to try and do is what? Find VOX and VOY. VOX would be 31 cosine 45. VOY would be 31 sine 45. And if you know your triangles, you'll also know that those are the same exact number. So 31, let's go sine 45. 21.9. So that means VOY is 21.9 and VOX is 21.9 meters per second because of 45. The question just wanted to know, how high should the net be placed? Well, it gave you an x, and there's only one equation good for x in a projectile, and that's VOX t. So x is 48 equals 21.9 t. Just a smidgen over 2, right? 48 divided by 21.9 equals 2.19. So 2.19 seconds. How high? And I'm just going to go straight for my second equation. VOYT plus 1/2 AT squared. This one's on our physics team stuff all the time. Let's see, 21.9 times 2.19. Half of negative 9.8 is negative 4.9. 2.19 squared. We can plug that into a calculator. 21.9 times 2.19, oops, 9 minus 4.9 times 2.19. Watching calculations done in the video is always so exciting. Square 24.45. So 24.5. And that's also the answer the sheet gives me on here too. So I really like that problem. Let's see if we can't find another one. And I think I got one more question I think we can actually try and do. And that's number 13. I really like number 13 on the review. So let's go back to do it. And I think I picked a few pretty good questions that definitely need to be known for the review. Let's see, number 13. We got this guy as a cat burglar. Cat burglar is hanging on to a wire. And so this is what the free body diagram would look like. And it's basically give you that in the picture already. I'm going to call that T1, this T2. And it says that the cat burglar weighs 600 newtons. And I think it even tells me the angle is 36 degrees. So all we got to do in this one is, well, that's it. All you need is this picture. And you do your sum of the forces X and your sum of the forces Y. You did this a gazillion times. T1 cosine 36 minus T2 equals 0 because it's stationary, it's static. Then for the y's, the only thing pointing up is the T1. So T1 sine 36 minus the only thing pointing down is the 600. And the physics is over. If you want to find your T1, T1 would just be 600 over sine 36. And then once we have T1, we can just substitute back in and get the other value. Divided by sine of 36. And that T1 would be 1,020 or 1,021, probably be better. And then if I want T2, all I've got to do is take that equation, 1,000. Here, I'll do 1,021 since that's really more. Cosine 36 equals T2. So answer cosine 36. I wonder if my calculator will actually like that, or if I should put like a... Hey, it actually understood it. I didn't have to put a time sign in there. 825, excuse me, 826. Whatever. We're definitely in the ballpark on that question at this point. Now, I think those are like the three questions that I really do like on here. Of course I do. They're three of the harder questions on the review that I gave out, I guess. But it's not supposed to be, you know, a super hard quiz. Let's do one more. And that's a student throwing something horizontally off a cliff, what I always call Thelma and Louise. So a student stands on the edge of a cliff, throws something horizontally at 19 meters per second. Cliff is 42 meters tall. Let's see, how long does it take to... I love this one. How long does it take it? Well, I wish every time I ask you for time, I had a go-to equation. Wait, I do. Y equals VOYT plus 1/2 AT squared. And in the case of this problem, VOY is 0 because at 19, it's horizontal. That's a VOX. So if VOY is 0, that means that's out, which means the object falls 42 meters. So negative 42 equals negative 4.9, half of negative 9.8. T squared. And let's see what we got. Negatives cancel. Take our square. Hey, where's my mouse? Take my square root of my answer, 2.93. And there is my answer to that. Now, if somebody wanted to find, usually this problem asks you to find x. So then you go back and VOXT. And you grab that 19 and that and get a product. But anyway, I think that's a pretty good short final exam review video. It's got 3 of my more favorite questions I would make sure I could do. But anyway, peace out, deuces, and all those other good, happy Christmas thoughts. Later. Bye.